everyone. This is a test one review session for ecore college algebra. We're going to go through all 25 practice problems together. The first one is using the distance formula to find the distance between 2 points, 6, -6, and 4, -4, -10. We need to give the exact answer. Okay, so just to remind us what the distance formula is, it's equal to square root of x2 minus x1 squared plus y2 minus y1 squared. And we get these values from the points itself. So 6 is x1, -6 is y1. Here it's x2, y2. So we're going to substitute. X2 is -4 minus x1 is 6. Squared plus y2 is -10 minus -6 squared. And we have a negative becomes a positive. And so we simplify it as -4 minus 6 is -10 squared. -10 plus 6 is -4 squared. And then we have -10 squared is 100 plus -4 squared is 16. And so we have square root of 116, which we can rewrite it as square root of 4 times the square root of 29. And we know square root of 4 is 2, and square root of 29 is not a perfect square. So we write it as 2 square root of 29. Okay, make sure you don't put this in decimal form and leave it in radical form. Okay, question 2, which of these is following is an integer? Okay, so we need to know what an integer is. Integers are whole numbers, with their negatives. And so whole numbers in this case is 5. Whole numbers and its negatives, so -10, -4, and 1. We don't include fractions as an integer, so only 5, -10, -4, and 1 are considered integers. Okay, question 3, we're going to simplify 5 y to the 8th over u 8 to the 8th times 4u to the 9th over y to the 7th. So here we can even rewrite this so that I switch the order so that the u's are kind of grouped together in one set of parentheses. So I'm going to put 4u to the 9th, write u to the 8th, and then write 5y to the 8th over y to the 7th. Why we can do that is because multiplication is commutative. That just means we can write 3 times 2 as 2 times 3. The order when we multiply doesn't matter. Okay, with exponent rules, when we divide the same base, what we do with the exponents is we subtract. So we have 4, and then u, 9 over 8 becomes 9 minus 8. And then this is times 5, y to the 8th. We're going to subtract that too, 8 minus 7. And that becomes 4u to the first power times 5y to the first power. Usually with exponent ones, we don't write that. And so this is 4u times 5y. Let's multiply the 4 times the 5, so we get 20uy. On to question 4, simplifying 4y to the 4th over u to the 4th, and 8u to the 6th over y. So here's another similar problem. And again, I'm going to switch the order, write this as 8u to the 6th over u to the 4th. And this becomes 4y to the 4th over y. So again, subtract the exponents. So we have 6 minus 4 times 4, and then the 4. And this, if you don't see an exponent, you assume there's a 1. So 4 minus 1. And so we have 8u, 6 minus 4 is u squared, times 4. 4 minus 1 is 3. So multiply 8 and 4, get 32 u squared y to the 3rd. Let's look at question 5. Square root of 756. Okay, so you might have to play around with the numbers, but you want to find the largest perfect square that will divide evenly into this radical. In this case, it's going to be square root of 36 times square root. That's a little too big. Square root of 36. Because 36 times 21 is 756. Square root of 36 is 6. Square root of 21 can't be simplified. It's not a perfect square. So this simplifies as 6 root 21. Okay, question 6 asks us to rationalize the denominator. And that just means get rid of all the radicals in the denominator. And we do that by multiplying the top and the bottom by square root of 28. And that gives us 4 times square root of 28 over square root of 28 times square root of 28 is square root of 28 squared. What that does is cancels the radical and you just get single 28. And then square root of 28, we can split it up as square root of 4 times square root of 7, which becomes 4 times 2 root 7 because square root of 4 is 2. And then we have 8 over 28 square root of 7. And from 8 and 28, looks like we can divide out a 4 from both numbers. So 8 divided by 4 is 2. Square root of 7, excuse me. And then 28 divided by 4 is 7. So we have 2 root 7 over 7. 7, we need to rationalize the denominator again. And we multiply by the denominator. We have to remember to change the sign. So we multiply by 5 root 6. That's called the conjugate of the denominator. Multiply by 5 minus root 6. And then we multiply the numerator, so it's 76. 5 minus root 6. And then the bottom, we can FOIL it out. So multiplying by FOIL means we multiply the first. Actually, let me just write it again. So, we have 75 times 5. Actually, double check that you're copying it down correctly. 76 times 5 is 380. And 76 times square root of 6 is just minus 76 square root of 6. And we're going to FOIL here. 5 times 5 is 25. And then 5 times negative root 6 is just minus 5 root 6. And then you have plus 5 root 6. And then root 6 times root 6 is just minus 6. Okay, these two terms cancel out, so we are left with 380 minus 76 root 6 all over. We have 25 minus 6, which gives us 380 minus 76 root 6 all over 19. Now I'm running out of space. I'm going to carry it over here. So if we have 380, I'm going to split it up into 380 over 19 minus 76 over 19 root 6. 380 divided by 19 is 20. 76 divided by 19 is 4. We have a root 6. So 20 minus 4 root 6 is the simplified solution. Okay, question 8, we're going to factor q squared minus 10q plus 25. The way I like to do these is I do the big X method, where you find what multiplies the last number, what adds to the middle number. This should be a plus sign. And two numbers that do that are -5, -5, and factors. Right? This breaks up into q and q. We're going to use a -5, -5. And this simplifies as q minus 5 squared. The way you can check is, right, you can just FOIL it out, FOIL what you think the correct factors are. At first, right? For times versus q squared. The outer term is q times -5. Q inside terms is -5q again. And then the last terms are -5 times -5, which is plus 25. The outside, inside, the middle terms are going to combine as -2q plus 25. So check your factors, multiply to the original expression, and so you know you're good to go. Let's take a look at number 9, factoring x squared minus 36y squared. So this uses a formula that a squared minus b squared factors as a minus b times a plus b. So I know x squared is a perfect square, and so is 36y squared. And so if we rewrite this as x squared, and we know 36y squared can be written as 6y squared, right? Because square root of 36, or I can rewrite 36 as 6 squared. I can factor this as x minus 6y and x plus 6y. This only works when you're subtracting two perfect squares, and this is called difference of perfect squares. For 10, let's simplify this rational expression, y squared minus 3y minus 40 over y squared minus 13y plus 40. This involves factoring the numerator, so we'll do that first. We'll factor y squared minus 3y minus 40. I'll do the big X method. What multiplies to -40 and adds to -3? Well, the two numbers that do that, let's have to think about this a little bit, are 5 and 8, with the 8 being negative, because 5 times -8 is -40, and 5 minus 8, the sum adds -3. And so then once you have that, you're done with the factoring. So the top numerator factors as y plus 5, y minus 8. Now we'll factor the denominator as y squared, factor minus 13y plus 40. And what multiplies to positive 40, the last term, and adds to the middle term, 13. In this case, it's going to be -5, -8. So those are the factors, y minus 5, y minus 8. And then we're looking to see, okay, which of the common factors cancel out. And they are y minus 8. And what we are left with is y plus 5 over y minus 5. Okay, let's look at 11. Multiply and simplifying this expression, x squared minus 9x plus 14 over x squared plus x minus 6 times x plus 3x minus 8. So this also involves factoring, so let's just go ahead and factor that part. X squared minus 9x plus 14. Big X method, what multiplies to 14 and adds to the b term, middle term. Two numbers do that are -7 and -2. So we've completed the factors, so it's x minus 7, x minus 2. And so I'll rewrite this top numerator as x minus 7, x minus 2. So that first part is done. We'll factor x squared plus x minus 6. What multiplies to -6 and adds to positive 1. So that's the 1 there. Two numbers that do that are positive 3 and -2. So we have x plus 3, x minus 2. So that part is done, factored, x plus 3, x minus 2. And then here we have the x plus 3. I'll just put in parentheses, and then the x minus 8. Let's see what we can cancel out. We can cancel out the x minus 2s, the x plus 3s. And what we're left with is x minus 7 and x minus 8. And I don't need to put the parentheses there because the factors, it's a single factor. Look at 12, a similar problem. Simplify and multiply x squared minus 5x minus 6 over x squared plus 9x plus 8 times x plus 8, x plus 6. So we'll factor this part here, x squared minus 5x minus 6. factors. Okay, so what multiplies -6 and adds to -5 are 3 and go with actually -6 and +1. So we have x minus 6 and x plus 1. Here's factors of x squared minus 5x minus 6. And let's factor x squared plus 9x plus 8. So that's what multiplies to 8 and add to 9. +1, +8. So x plus 1, x plus 8. We're done with the factoring of the denominator expression. And then we just carry down the second part, which is x plus 8, x plus 6. Okay, so let's cancel here with the x plus 1s cancel, and then the x plus 8s cancel. What we're left with are take a look at again for 13 using the distance formula to find the answers between the points 0, 3, and -8, 5. So here's the distance formula again, x2 minus x1 squared plus y2 minus y1 squared. And 0, 3, here's x1, y1, x2, y2. So we have square root of x2, which is -8, minus x1, 0. I'll put these and square that. Y2 is 5, minus 3 squared. And what 0 is -8 squared. 5 minus 3 is 2 squared. So we have square root of 64 is 4, which is square root of 68. And that can be broken up into square root of 4 times square root of 17. And square root of 4 is 2. Square root of 17 can't be simplified. Again, make sure you don't put decimal form. Write your answer in exact form. That means you want to leave those in. Okay, 14, finding the midpoint of the line segment with endpoints -6, -5, -7, -7. I'll label these x1, y1, and x2, y2. And the midpoint formula is x1 plus x2. Add those x value and divide by 2, y1, y2, and we divide by 2. Okay, so x1 plus x2 is -6 minus 7, plus -7, 2, and then y1, -5 plus -7 over 2. -6 plus -7 is -13 over 2, so that's the midpoint of the x values. -5 plus -7 is -12. So that's -12 over 2, which simplifies to -6. 15, again, let's do the midpoint of line segments 9, 2, and 8, -3. x1, y1, x2, y2. And so again, the formula is add the two x values together, 9 plus 8, divide by 2. Add the two y values together and divide by 2. So we have 9 plus 8, which is 17 over 2. 2 plus -3 is -1 over 2. And that's it, because those fractions can't be simplified. -16 is solve the following equation for x with -4x plus 4. Let's put a line in between. We have to solve for x. So we want to get rid of this +4 by subtracting both sides. Get rid of that 4, and we get -4x is equal to 4. And then we divide by the number in front of x, because this is held by multiplication. Divide both sides by -4. We get x is equal to 4 divided by -4, which is -1. You can check your solution by substituting it back into the original equation. -4x plus 4 equals 8. We substitute x as -1 plus 4. And we have 4 plus 4, and that does give us the right-hand side. Okay, 17 is a little longer, but similar idea. Solve the following equation for x. With when you have these many terms, always combine like terms first. And so what we mean by that is on the left-hand side, you have negative 7x minus 2x. That combines to negative 9x. And we have negative 10 plus 15x. And then we're trying to get all the x terms on the left. So we want to get rid of this 15x by subtracting 15x on both sides. Then we have negative 11 minus 24x equals negative 10. And then we need to get rid of this negative 11 by adding 11 to both sides of the equation. So we have negative 24x is equal to negative 10 plus 11, which is positive 1. And lastly, we divide by the value, the number in front of x, negative 24. And we have x is equal to negative 1 over 24. The placement of the negative doesn't really matter as long as you have a negative in your answer. Okay, 18 asks for another solving of the following equation. Negative 5 minus 7x minus 9x minus 4 plus 12x. Again, we're going to combine like terms first. Combine negative 7x minus 9x. That's negative 5 minus 16x and negative 4 plus 12x. Let's get rid of the 12x first by subtracting 12x on both sides of the equation. And then we have negative 5 minus 28x is negative 4. Let's add 5 to both sides. And we get negative 28x equals 1. And finally, we divide both sides by negative 28. And then we get x is equal to negative 1 over 28. 19 asks us to add the following complex numbers and write the answer in standard form, a plus bi. So here there's parentheses, but there's nothing to distribute, so we can take the parentheses off. It's 4 plus 12i. And there's nothing to distribute, so we can take the parentheses off. 7 minus 7i. Combine the like terms. 4 plus 7 is 11. 12i minus 7i is plus 5i. I don't like combining like terms and numbers together. It's called the real parts. And then the imaginary parts, the i's. Okay, let's look at multiplying complex numbers. Negative 9 plus 8i minus 2 minus 13i. So here we can do the FOIL method, or we can also do something called the box method, and I can show you both ways, and you can decide which way is better for you. So FOIL, first times first, negative 9 times negative 2 is positive 18. The O stands for the outer terms, negative 9 times negative 13 is positive 117i. Inside terms, 8i times negative 2 is negative 16i. And the last terms, 8i times negative 13i is negative 104i squared. Yeah, I squared, remember that gives you negative 1. And so this really becomes negative 104 times negative 1. And I'm going to also combine these two together because they're like terms. So it becomes positive 101i. And bring the 18 down. And so what we have here is 18 plus 10i plus 104, because negative 104 times negative 1 is 100. And we combine the 18 and the 100 together, get 100. Oh, forgot that's a 4. Sorry about that. 104. 18 plus 104 is 122 plus the 10i. The box method is similar. It's just you're doing FOIL using a box. And so let me erase this for a second. box here, and then get -9 plus 8i, and -2 minus 13i. Then you're just multiplying the boxes together. So we have -2 times 19, which is 18. -2 times 8i is minus 16i. -9 times -13 is 100, positive 117i. -13 times 8i is negative 104i squared. So it's you still get the same thing. And then you can combine these together and get 18 plus 101i minus 104i. Got the squared here. Squared, and you know you can replace that with -1. So if we add that to 104, we have 18 plus 101i. So same thing, 122 plus 101i. Solve the equation y squared plus 2y minus 3 equals 0 by factoring. So let's factor this. We have here what multiplies the last term and adds to the middle term. Two numbers that do that are positive 1 and -3. So it factors as y plus 1, y minus 3. And we have to set it equal to 0. And then set each factor equal to 0, y plus 1 equal to 0, y minus 3 equal to 0. We subtract 1 on both sides, and y equals -1. We add 3 on both sides, and we get y equals 3. And so your solution, you're going to enter it as -1 and 3. Here's another one, factoring. And what multiplies to -72, the c term, and adds to the middle term, -1. And that's going to be 8 and -9. So 8 times -9 is -72, and 8 plus -9 adds -1. So our factors are y positive 8 and y 9, set it equal to 0. Let's set each factor to 0 and then solve. Here we subtract 8 on both sides and get y equals -8. 0 minus 8 is -8. And then here we add 9 to both sides and get y is equal to 9. So the solution is -8 and 9. Okay, 23 is solving an inequality. We have -5x minus 1 less than or equal to -4x plus 5. Make sure you want to gather all the x terms on the left. So let's get rid of this -4x and cancel it so that goes on. The x terms all gather on the left-hand side. So we add 4x and get -1x minus 1 less than or equal to 5. And then we add this one, get -1x is less than or equal to 6. And then we divide both sides by -1. And remember, whenever we divide by -1, the inequality switches. And so we get x is greater than or equal to 6 divided by -1. This only happens when you divide both sides by -1. And we need to give the answer in interval notation, not this notation. X greater than or equal to -6 means if you have -6, you have a bracket at -6, and you're going to shade all the numbers to the right. So this interval notation is -6 all the way to infinity. Let's see, 24 is which one is an irrational number. So I guess we need to talk about what irrational numbers are. Irrational numbers, actually, let's talk about what rational numbers are. Rationals are fractions, integers, decimals that stop or repeat. Stop or repeat. I think that covers all um, the rationals. So irrationals are everything else. So here I can say, okay, this is a fraction, so that's a rational. This one has a decimal that stops, and this is an integer. And if we look at square root of 15, because it's not a perfect square, those are irrationals. So, and then square root is 21 as well. So irrational numbers. Okay, last one, 25. Let's simplify 11 root 8 over root 6. And again, we multiply the top numerator and the denominator by root 6. Gives us 11 times root 8 times root 6, which is root 48. Root 6 times root 6, this becomes square root of 36, which is just 6. 11 root 48, I can simplify that as square root of 16 and square root of 3. And just carry down the 6. And this becomes square root of 16 is 4, so 11 times 4, root 3 over 6. Then we get 11 times 4 is 44, root 3 over 6. And from 44 and 6, we can divide out a common factor of 2. So we are left with 22 root 3 over 3. I hope that you found this, the review of the exam 1 practice problems helpful. Again, if you have any questions, feel free to reach out, and good luck on your test 1.